Hello everyone, here is Costa Sierra Victor 3 Oscar Romeo Alpha, and I would like to show you today a special method of using capacitors, fixed capacitors, to create voltage controlled oscillators. I have built the first stage of my mini VFO, and what I would like to try is to replace these capacitors here with just two capacitors connected in series. The configuration I want to achieve is this one: the inductor, just ignore the rest of the oscillator circuit here, the inductor, the two capacitors in series, the 1 mega ohm resistor, and I have replaced that with 100 kilo ohm, and I will show you why, and then the simple potential divider to vary the voltage throughout these capacitors. Now this might be new to some of you, but you can actually use capacitors, fixed capacitors, to and change their capacitance by applying a voltage to them, similar to what a dual variacap diode would do at this place. However, I will show you that this is not a good thing to do in oscillator circuits, at least as far as I have tried up to now, and I will show you the reasons why. So let's build this configuration here of the resonators using my mini VFO. And here's the circuit. You can see here is a 10 nanofarad capacitor. This is one of these very cheap capacitors that you that you might find from the Asian market. I have to say that the cheapest the capacitor is, the more crappy the capacitor is, the better it works, as it pulls the frequency of the oscillator as much as possible. And here's just another capacitor connected in series to this, and here is our coil. And here is the potentiometer that we will use to change the frequency, to change the voltage to the junction of these two capacitors, and then change the frequency of the VCO. So, an interesting point is that this 100K series resistor with which is connected in series with a wiper of the potentiometer. If you replace this with a 1 mega ohm resistor, you have some lag when you tune the potentiometer and when the VFO changes frequency. There is some lag. I suspect this is probably because the current is very low and the capacitors are not charged very rapidly. So I have replaced this with 100 kilo ohms, and the lag is much lower now. Now the top capacitor in the series, the top capacitor here is 470 picofarads, and the bottom capacitor, the big one here, is 10 nanofarads. So I have switched on the my commercial receiver, and you should be hearing the tone out of the oscillator right now. Notice that the oscillator is not stable in frequency, whereas when the capacitor there is replaced with a variable air capacitor, the frequency is dead stable. So let's try to vary the frequency a bit. Hopefully you will be able to hear the tone. I have. Okay, let's do that again. With these particular capacitors, I'm able to switch to vary the frequency of the VCO at about 40 kilohertz at 40 meters. But if you replace the top capacitor with another value, you should be able to vary it even more or even less if you want to, because this capacitor is already 10 nanofarads, so the series capacitor is what